Every once in a while, science reaches a moment where anticipation outweighs certainty. A moment when the question becomes louder than the answer, and when the entire astronomical community waits with bated breath, eyes fixed on a single set of images. Today, we stand on the edge of such a moment. NASA is expected to finally release the HiRISE images of 3I/Atlas, the interstellar visitor currently slicing through the inner solar system. For more than 43 days, these images remain locked behind digital doors, not because of scientific caution, but because of bureaucratic delay. And so we waited. We watched the sun rise and set. We watched telescopes from Europe and China release their own images. We watched speculation ripple through the public, through newsrooms, through classrooms, and we all asked the same question. What is 3I/Atlas? Is it a natural comet? A fragmented relic from a long-dead star? A probe? A messenger? Or simply a piece of cosmic debris behaving in a way we do not yet understand? The HiRISE camera, the most powerful imaging system ever placed around another planet, may finally give us answers. Not because it will show a Hollywood-style spacecraft or a crystalline nucleus, but because a single picture can be worth 1,000 hypotheses. Before these images arrive, I want to take you on the journey behind them. The physics, the politics, the mystery, and what I believe we might see when the truth is finally shared with the world. Many people ask me, Avi, why are scientists so obsessed with getting these HiRISE images? What difference does one photograph make? In astronomy, one photograph can reshape the entire narrative of an object. HiRISE has a clarity 3 times sharper than what Hubble provided when it first imaged 3I/Atlas last July. While Hubble gave us a curious, almost ghostly look at an anti-tail pointing toward the sun, the geometry was ambiguous. We were observing the object almost edge-on, just 10 degrees from the sun's direction, like trying to judge the height of a skyscraper while standing directly beneath it. HiRISE changes everything. From Mars orbit, it captures a side view of the object, unobstructed, clean, and free of the blinding solar glare. It won't resolve the nucleus directly. It's still too small at 29 million kilometers. But it will reveal whether the anti-tail is real, the direction and structure of the jets, the true extent of any fragmentation, how sharply the brightness drops from the peak pixel, and most importantly, how large the nucleus must be to produce what we see. A single bright pixel can reveal the difference between a 500-meter rock and a 5-kilometer fragmenting object. And in science, such differences are seismic. We may learn in one afternoon what months of speculation only circled around. Now to the question the public has asked repeatedly. Why did NASA hold these images for so long? Ironically, the reason has nothing to do with science. For 43 days, the United States government operated under a continuing resolution freeze, a bureaucratic limbo which trapped the release pipeline for HiRISE data in administrative paralysis. No conspiracy, no cover-up, just institutional delay.
But let me be clear, science should never be held hostage by bureaucracy. The universe does not wait for political calendars. Comets do not pause their trajectories because an office is temporarily unstaffed. And interstellar visitors, objects we may never see again in our lifetime, certainly do not adjust their behavior to fit federal paperwork cycles. 3I/ATLS passed within 29 million kilometers of Mars on October 23rd. The HiRISE instrument was awake, recording, but the images remained unseen. Meanwhile, ESA released their images. China's Tianwen-1 released theirs. Amateurs posted daily tracking data. Japanese observatories shared color curves. Only NASA remained silent, not scientifically, but administratively. And in a moment of global curiosity, that silence echoed louder than any data. Let's revisit the most perplexing feature of 3I/ATLS, the anti-tail. Comets traditionally produce a tail that points away from the sun due to solar radiation pressure. But the July 21 Hubble image showed something astonishing, a bright, elongated structure pointing toward the Sun, the opposite of what dusty comets do. There are natural explanations: geometry, viewing angle, heavy-grained fallback. But those explanations depend heavily on Earth's perspective. HiRISE gives us the first clean geometric vantage point, a true side view. If the anti-tail persists, extends, or shows structured curvature, then something more complex is happening than solar radiation alone can explain. It could be unusual dust grain distribution, ion-tail interactions, sublimation-driven jets, or a mechanism that behaves like directed propulsion. I'm not saying it is propulsion. I'm saying the shape of the anti-tail will tell us which models survive and which fail. Science is not about certainty, it is about elimination. Another major puzzle is whether 3I ATLS is a single intact object or a collection of fragments behaving like a swarm. When I analyzed the mass loss rates near perihelion, the numbers demanded 5 billion tons of ejected material. To produce that much mass, the nucleus must have enormous surface area, far larger than early estimates. But if it has fragmented, each piece contributes its own surface area, making the numbers physically reasonable. HiRISE may reveal faint subnuclei, uneven brightness regions, discrete dust plumes, or separated objects in the same orbital path. If so, the object we speak of is not 3I ATLS. It is the remnants of 3I ATLS, an interstellar body torn apart by the Sun. But if HiRISE shows no fragmentation, if the jets appear coordinated, if the brightness remains concentrated, then we must consider the alternative, that the observed jets behave more like controlled emissions than chaotic venting. As I said on television, if the jets are natural, they are the most powerful ever recorded. If not, they resemble engine-like behavior. HiRISE is the key. There is a poetic symmetry in the fact that Mars, the first planet humans hope to step on, is now our outpost for studying visitors from other stars. HiRISE gives us a sideways look at the anti-tail, jets illuminated from different angles, high-resolution brightness gradients, pixel-level constraints on nucleus size, and direct visualization of dust shell structure. Think of it as a crime scene investigation. Earth gives witness testimony. Hubble provides blurry security footage. Tianwen-1 offers a partial angle. HiRISE gives us forensic evidence. If 3I ATLS is one body, HiRISE will show uniformity. If it's many, HiRISE will show complexity. The universe reveals itself through geometry. Change your angle and the truth comes into focus. Near the end of my Medium article, I mentioned another object, Comet Bernardinelli-Bernstein, or C 2014 UN271, or BB. Why bring it up now? Because context matters. 3I ATLS is unusual, possibly unprecedented, but BB is colossal. 100 kilometers wide, 10,000 times more massive than 3I ATLS, traveling from 40,000 AU, a relic of the solar system's birth.
Unlike 3I/Atlas, BB is predictable, slow, chemically typical. CO2, NH3, CO sublimating even at 25 AU. If 3I/Atlas behaves like an outlier, BB behaves exactly like an Oort cloud giant should. The contrast matters. It shows that our models work, except when they don't. Science advances in the gap between the expected and the unexpected. One of the most important lines in my Medium post is this: the truth about 3I/Atlas will be revealed by publicly shared data, not by narratives or gatekeepers. This is not about believers versus skeptics, conspiracies versus transparency, aliens versus comets. This is about the central rule of science. Evidence speaks louder than narrative. When the HiRISE images arrive, they will end months of speculation. Not completely. Data never ends curiosity, but meaningfully. We will finally know.
Is the nucleus large or small? Is the antitail real or an illusion? Are the jets chaotic or structured? Has 3I/Atlas fragmented or survived perihelion? Is its behavior consistent with propulsion? There is no reason for secrecy, only reasons for openness. When the universe hands you a puzzle, you don't hide the pieces, you lay them on the table for all to see. If the sources are correct, the images will be released within days of November 14. When they arrive, astronomers around the world will pounce on the pixels like detectives on a fresh lead. Every brightness profile will be graphed, every tail angle measured, every jet traced, every fragment counted, every anomaly cataloged. What we learn in the next week may define the rest of the 3I/Atlas story. Until then, we watch, we wait, and we allow ourselves to be curious, because curiosity is humanity's oldest engine. Long before rockets or rovers, our ancestors had another form of propulsion, the courage to look up and wonder. 3I/Atlas is not a threat. It is an opportunity to learn, to question, to be humbled, and perhaps, just perhaps, to take a small step toward answering the oldest question of all. Are we alone? When the HiRISE images finally appear on public servers, millions of eyes will see them. Some seeking beauty, some danger, some answers, some questions. But whatever they show, remember this. The universe is not obligated to make sense to us, and yet, piece by piece, pixel by pixel, it does, when we pay attention. We do not fear the unknown, we investigate it. That is the spirit of science. That is the heart of discovery. And that is why this moment matters. Because soon a single image, taken by a camera orbiting a planet we have not yet walked upon, may show us the first clear glimpse of a visitor from another star. And when it does, we will be ready. Stay curious,